is able to see my screen? Chitra, is my screen visible to everyone?
Yes, sir.
Okay. So I will do one thing. Let's do a recap of whatever we learned yesterday. I'm opening that notebook which we gone through yesterday. So it will be a quick recap now. Yesterday we learned that how to write the print statement with the text. So with the print, for the print statement, we need to write the text with the quotes. It will be single quote or double quote. Both will work in that case. And if we have to comment some particular line, if it is a single line, we can put a hash in front of that. If we have to write the multiple comments, then we can write, we can put 3 quotes, either single or double like that, both will work. Next, we learned that it is possible for us to do the calculation in Jupyter Notebook. The environment which we are using is Jupyter Notebook, and this is hosted in cloud. It is a Google Colab is facilitating that environment for us. We learned that how to initialize the variable. Like we can initialize variable name will be on the left side and the value will be on the right side. We can define various variables like string, integer, float, etc., boolean. We learned all these things, and we also learned there are a few libraries which are inbuilt in Python, and there are a few libraries which are third-party libraries are there, which is developed by somebody, but anybody can use them. So like import time is the way to import a library, and time, which is inbuilt library, and this is the way we can use those library. We can write the name of the library dot the function which we want to use it. And in case I will write one more thing here. Let us say we are not too sure about that function or library, that how to use it, what are the functions or properties within that. So we just have to write the name of the object or function, and we need to write a question mark along with that, and we need to just run it. So you will be able to see all the details related to that library or function on the right side. So this particular feature is specific to the editor. We cannot say that this feature will be applicable and available in all the editors, because there are multiple Python editors are available in the market. So this is specific to, I would say, Jupyter Notebook. So we learned that how we can do various operations within the variables. Like we can add, divide, multiply those variables. We can use a string, and we can use those string variable along with a Python string variable along with the Boolean variables, and Boolean variables along with the integer or float variables. How we can use it, that we have seen. We have also seen that various data structures which are available in Python, like list, tuples, sets, dictionary. We have gone through with some of the list variables, and we have seen that how we can use them, how we can store the data within the list, how list can be added between each other, what are the limitations of the list. And because of the limitations of the list, how we can overcome with those limitations? By using NumPy. This we have seen. We have also seen that how to use if then else and loops. So today we will be looking at little more on NumPy, little more on pandas, and after that we will move on to building a new strategy, that how we can build a new strategy. So yesterday we saw that, let us say list A has few elements. I would say 10, 20, 30, 80, 70. Let us say it has 5 elements. I ran it. And let us see what are the values inside this again. How does it look like? Okay. Now let us define another list. List B. It has almost the same structure but different values inside that and different elements. It has 5 elements, but values are different. I will be repeating few things which we have discussed yesterday, because those things are important. We should not miss them out. Everybody should be clear on that. So let us say if I'm trying to add these two lists, what happens is it adds both the elements into one single list. So let us say we want to add element of list A to element of list B. So that is not possible here. And let us say I want to divide and see what happens if I want to divide elements of list A with B. Then it doesn't happen. This we tried yesterday. So this doesn't happen. So for that, what we have done, there is a library, very popular library in Python, NumPy. We have defined that we can convert any list variable into NumPy array. So I'm declaring another variable, np underscore list A is equal to np dot np.array, and I will pass the list A into it. Similarly, I will do the same thing for list B, and let us see how it looks. So if you see list A, it has all the values of, this is NumPy array now, which has all the value of list A. and let us say how list B looks like. So both of them has the values of list A and list B. But when we do some actions on them, so I defined list C, where I'm dividing list A divided by list B. Let us see whether it shows any error or not. No, it went well. And how does it look like? Yeah, this is how it looks like. So fine. So, but there is one thing we observed. This is 1D array. So NumPy is a 1D array, but it is possible to make it ND array. Means we can multi-dimensional array. We can convert it into it. So converting 1D array into multi-dimensional array is a little complicated job. So there is a solution of that is also there in the Python, that is pandas. So panda has an object called data frame, which looks very similar to Excel. So I'll show you how does it look like. Pandas as PD. So like in Excel, I will open one Excel now. To make it, to show you how it will look like, how both of them are similar to each other. Like in Excel, we have columns and rows. Similarly, in pandas also there are columns and rows. And most of the operations are almost similar like we perform in the Excel. So let us say I created one pandas data frame. We call it data frame here in the pandas. And we generally define it with df. So I'm pv dot, let me run it first. pd dot data frame df. So if we see, we created a data frame which is blank. It doesn't have any row or column. It is just like you can think like it's an Excel blank sheet. So let us say I add one column into it. List A. So what I will do, I can initialize this with NumPy array. That is the beauty of it. So Panda data frame is very much compatible with NumPy array. So what I am doing is, I created one column in data frame df, where I'm initializing that with NumPy array. So it initialized. Let us see how does it look like now. So see, it created one column list A, and it has the index values starting from 0, 0, 1, 2, 3, 4. So it looks like very much similar to Excel now. So what we will do, we will add one more column now. list B. So let us see how data frame DF looks like now. See, it looks very similar to Excel. It has 2 columns and it has multiple rows. The row IDs are defined as index, which is starting from 0. And we can do multiple operations on that. So we will do one thing. We will see how data frame and NumPy looks like and what are the various functions in that. But we will do this along with the strategy. We will build a strategy and we will keep on exploring new functions and attributes of data frame and NumPy there. I hope it is comfortable to all of you. If anybody is not much comfortable in data frame or NumPy, please tell me. Or you want me to explain it, the details first? Great. So everybody is agreed with me. So we will go ahead with the new strategy. So there are various ways to initiate a data frame. One is the way we just created. We have inputted some value in different columns of data frame. And another way is we can upload Excel, CSV file, flat file, JSON file. We can initiate data frame through multiple ways. But because we will be not using these things as of now, you can explore these by yourself, these functions by yourself later on. So we'll be focusing on one particular strategy. We'll see how to develop a strategy. Okay. So I'm starting, let's write some notes. If we have to build a strategy, I'm writing. So I'm a little slow in typing, please be with me. Testing the strategy. Okay, so what are the things which are required if I have to backtest one strategy? Will you please tell it to me? Just write on the question answer section. Please write it there. Historical data, yeah, very correct. What else do we need? Stats, okay. Strategy, absolutely right. We need a strategy actually. If we need to build a algo strategy. What else do we need? Plan of, absolutely correct. Plan of execution. What else? Matrix to measure, absolutely right. Matrix to measure that once we complete the backtest, then what are the performance criteria on which we will identify or backtesting went correct or not. This is very much correct. What else? Strike rate. Yeah, this will fall under matrix itself. So very good. I will just list down these things. First thing first, we need a strategy or some idea if we have to backtest a strategy. So I'm writing, we need to define the logic. So at very initial stage, I would say I don't have strategy. I just have some idea in mind. Or idea. I will convert that idea or logic into strategy. Now I have some idea or logic, but I need to see on which particular segment I need to run. In whether it is going to be equity, commodity, forex, crypto, what it is going to be. So identify the segment. Okay, what else do we need? And okay, so we need the logic idea, we need to identify the segment, we need to decide, we need historical data, or we need historical data, we need the frequency of the data, on which frequency we need the data, and what is the duration of the backtesting. What else? We need the performance matrix. Okay, so all these things will fall under plan. We will be planning these things before we start. So this is plan. And what are the resources required? We need the data vendor, I would say. From where I will get the data? Data vendor, or maybe API, data API. Either of this I need. I need some function to do the backtesting, or I may need to write the backtesting function by myself. I need, if I will be using some technical indicator, then I need to write the technical indicator function, or I need some library for that. Technical indicator library. What else we need? We need where I will be hosting that infrastructure part, where I will be hosting my Algo, whether it is going to be cloud, like it could be Google Colab, or maybe in my own computer, or where exactly. So hosting. So this is all about. I need. We will see if we need something more. We'll add into it. Oh, the formatting went for the toss. It's okay, but we understood what exactly we need. So first thing, we need the logic. Let us say we go for a simple moving. We'll go as of now with very simple logic, which all of us understand, including me. Let us say simple moving average crossover. So we are SMA crossover. Strategy. So this is what we are looking for. So what we will define one simple moving average. One simple moving average. If the close price of today is more than simple moving average of that period, then we will buy and we will sell it after that. Let it be only long strategy. We will not go for short strategy. Let it make it more simple as of now. So okay, we have the strategy as of now. So what exactly we have? We need the historical data. And for historical data, it's very difficult to get the intraday data. So what we'll do, we'll go for the daily frequency, which is easily available in the market. And we don't even need the data vendor for that. There's two APIs or Python wrappers are available by which we can fetch the daily frequency data. So what I will do, there is a library called Finance. That is Yahoo Finance. Somebody
Hello, sir. Sorry to interrupt you, Mr. Guglani.
hello. Yeah, is it audible now? Okay, sorry for the disturbance. I couldn't find it out because I was focusing on the algo. Great, fine. So I hope I didn't miss out few more things. So now we were on the steps that we have to install the library which we need to use. So there is one library, Vibe Finance, which is based on Yahoo Finance data. Somebody has developed the library for us. So if we have to use that library, first we need to install that into our environment. So this is the syntax to install. Pip install Vibe Finance. So I'm doing this. You can also do it in your computer. See, by doing like this, we install this library. So now because it is installed, if we have to use it, we need to import it once. So I will be importing it. Vibe Finance as YF. It is imported. So now we will be using it. So this particular library has a function. If we pass the name of the ticker or the symbol, and if we pass the period, it returns the data in the form of data frame. So what we will do, df is equal to yf dot, the function name is download. So first we need to give the name of the ticker. Let us take the example of Apple, which is listed in US. Now we have to give the start date. We need to give the period or the start date. Let us say we give it for 5 years. Next it is saying interval. I would say period is equal to 5 years. Interval is equal to 1 day. And let us run it. Let us see whether we can run it or not. Wow, wonderful. No error. Let us see how does it look like. So like I told you, data frame looks like an Excel itself. So here it is showing all the columns just like it shows in the Excel. And it has one column also, date. So we have open, high, low, close, adjacent, close, and volume. If we want to see only few rows of data frame, we can do like that, df dot head. Then it will show the top rows, whatever number of rows we want to show it here. Yeah, see, only 5 rows it is showing because I have given. And let us say you want to see the tail. It's very simple. Just telling few functions to you, which will be easier for you to use it later on. Okay, now we have the data with us. We have the historical data. So let us focus on the strategy part. We have the strategy with us. Strategy, we have SMA crossover. So let us define one SMA variable. I'm giving the SMA period is equal to 5 as of now because I don't know that what period will be good for this strategy. So I'm giving 5 as of now. Let us see it works or not. And I am defining one more column, SMA underscore plus SMA is equal to so how will I come with simple moving average? For simple moving average, I need to have the rolling period. So not rollback period, rolling period. I need to look back and see for some particular window, I need to find out the mean for that. This is simple moving average. I hope all of you agree with me. So I will be taking the closing price first. After that, I will do the rolling. Rolling means I will look back. So that period I have taken as 5. So instead of hard coding this, I will keep this as a variable 5 dot mean. So for mean average, the function is mean here. So data frame and NumPy both are vectorized function. So if I'm doing this particular function, df close dot rolling SMA period dot mean, it means this whole function, this mean function will be applicable for all the whole column, all the values of close. I don't need to write any loop or if condition or anything else here. This is the beauty of data frame and NumPy. So I did it. Oh, it is showing some error. Why? What is the error? Let us look at the error. It is saying type error must be str not int. So where it is giving the error, we need to look at it. It is pointing here df SMA plus SMA period. So if you remember yesterday, if we have to define a string, then we have to put that phrase into that quotes, whether it's single quote or double quote. So that's what we have done here. So And string can be concatenated with the string, not with the integer or float. So that's why it is saying it should be string, not integer. So here we are trying to add integer with the string. That is the error. So what we will do, we will convert this into string. So for converting any variable into string, this is the syntax. We can convert float, boolean, and integer into string using this syntax. And I will use this particular variable to define the name of simple moving average. See, it worked. Wow. Now let us see how does it look like again. So every time we do something, we are beginner. So every time we do something, we will check it whether it's working fine or not. Because if we complete the whole algo and after that we look, we might have done some severe mistake in the beginning itself. So we'll keep on checking. df.head. So let us look only 10 rows maybe. Try to look everything. Okay. So it added one more column, SMA5. Why SMA5? Because we have added SMA underscore plus string of SMA period. SMA period we have given as 5. So that's why SMA5 is added. And why it is showing NA. Can somebody tell me why there is no value for first 5 rows? Will you please type your answers there? Why there is no NaN means not a number. You can say it's a blank in simple layman terms. So why there is blank values or NaN in beginning of top 5 rows of SMA5? 5 days rolling, yeah. Absolutely, I fully agree with you, with all of you. So because for calculating 5 days of moving average, simple moving average, it needs at least 5 days of closing data. So that's why it started from row number 6. There is no value, there is no simple moving average for initial 5 rows. Wonderful. So, but if we don't have if our logic is based on simple moving average and if we don't have data in that, what shall we do with that? So let us remove those rows. I will add one more row. df. So there is a function in data frame called drop NA. NA means not a number. There is a function called drop NA. If I use this, it will drop all the values which has not a number. Let me run that. Oh, it removed. Wonderful. So as I told, because we are the beginner, we will check all the values at each stage. We'll check it again. It is showing NaN again. Why is it so? Why it didn't remove that? It didn't remove because whenever in most of the functions of the data frame, how it works is either we store the operations, after operations, whatever we are performing on the data frame, we store this in another object, or we apply this in that object itself. So for example, there are 2 ways of doing that. df is equal to df.draw. I'm writing the function again. So if I do like this is one way of doing this. df2, we can store that in another data frame. Or I can do like that. If I want to apply this drop NA operations in df itself, then I would say in place. drop NA will be applicable on DF itself. I hope you are getting me. So now drop NA will be applicable on DF itself. This will be visible now to me. See, now an N is removed. Great. So let's move on. We have data frame, we have a simple moving average. So what is the logic we are planning to implement? Let us decide, let us create one more, variable, standard deviation. I hope everybody knows what is standard deviation is. So I will add one more that will be, we will use this particular column to see when we have to do the entry, when we have to do the exit, along with simple moving average. So I have created one more column, standard deviation. The syntax will be almost similar. We'll take the closing price, we'll take the rolling period, and instead of mean, we'll say STD, standard deviation. So I'm running this all over again. This is, I don't need to run it, I will remove it. Run it. So as you can see, I have two variables now, simple moving average and standard deviation. So I have the logic that if I'm writing long condition, because my strategy is long. DF, close price. If DF close is greater than if current close price is greater than the simple moving average of last 5 days, then we'll take the long position. So let us see how does it look like. So yeah, it is working. It is showing me true and false values in that when I have to enter, when I have to exit. So, but exit criteria is not here. It is only that when I need to enter, when I should not enter. So what should be the exit criteria? So let us say I will exit when long, I will say this time long square of condition. So I will exit when it is greater than simple moving average plus it is greater than standard deviation. First standard deviation. I hope all of you are getting me. So my criteria is if the current close price is greater than simple moving average of last 5 days plus standard deviation, then I should exit. Let us see it again. But one standard deviation looks like I'm exiting too early. Let us exit little late. So I will define one variable. let's say it is 1.5. So I will exit when standard deviation is 1.5. I will enter when it is more than simple moving average. So I will run it again. So let us say how DF looks like now. Wow, we have long condition, we have square of condition. So now what is next? Both the values are implemented. So we'll try to make it more simple now. We will make it one column. Let us say position column. When I will take the position. So you must have seen if then else in Excel. Similarly, here also we have few if then else kind of criteria where condition is there. We can use NumPy here because data frame and NumPy both are compatible to each other. So whatever columns of data frame we have, we can use NumPy functions over there. So I will be doing so because we will be using NumPy. We'll have to import NumPy first. Import NumPy. Yes. Next one. So I will. What my plan was, I will create one single column where I will see what is the position I'm going to take. Whether I'm into the position or not. That's what we have to do. So I will write a function np dot where. It's kind of where condition, just like in Excel we write if then else, something like that. So I would say if long condition then one. So if the condition is long, then it is 1. If the condition is not long and we'll putting another nested condition actually, then it will be -1 else 0. Let us run this. Okay. I will see what is the value again in data frame. Okay. So it is saying, did I do something wrong here? Okay, there is one problem here. I have defined the long square of condition if close price is greater than simple moving average and again, yeah. Instead of standard deviation, I have put simple moving average. This I have corrected now. What is the next problem? What if the stock will go in the opposite direction? What will I do in that case? So in that particular case, I need to define the stop loss actually. If it is going in my direction, then this is the target. 1 standard deviation, 1.5 standard deviation is the target. If it is going in the opposite direction, then I will see if the close price goes below standard deviation. I would say long, let's say. str std period is not defined. Okay. So now we have two square of condition, but we don't need two square of condition. We need actually just one. So what we will do, we will say first condition is for my target, second condition is for my stop loss. So I would say either first condition is met or second condition is met. So when we want both the condition to be met, then we will say and can be used like this or can be used by this. And if we want only one condition to be met, either of the condition, then this is or. So I ran this. Let us see how does it look like now. So we have long condition, we have long square of condition. So we can, and we have position. So we can see position is 1, 1 because it is long condition. Long square of condition is true, then here is this -1. So like that. I hope you are getting me. So I request all of you to just look at this code, and if you have any query, please let me know. Then we'll move it further. So I will remove all the comments. So this is the code. Please go through with this and see whether if you are facing any issue in understanding this or not. So I can focus only on one screen at a time. So I hope you must have gone through with the code. I will just see the questions now. I got a few questions. It's not showing because 5MA will start from 5th day. Okay, great. What symbol you used for or condition? Okay. Which one keyboard? That is a pipe. It's a pipe. You can search. The symbol name is pipe. Yeah, you can also use or also. My friend already replied to you. Either or pipe, both will work. So I hope there is no question. So then I will move on. So I will just go through with this. So first here, we have defined when we have imported the library yfinance. After that, we have downloaded the data from yfinance into data frame df. Then our strategy was, if simple moving average of last 5 days is or current close price is more than simple moving average of last 5 days, then we'll take the long position. So here we have defined the long position. Here we have defined the simple moving average of last 5 days. Here we have defined the standard deviation. And here we have defined the condition, like close price is greater than simple moving average, plus we have made it little, this is a square of condition. If long condition is if close price is greater than simple moving average, and this is target we are defining if close is greater than simple moving average plus standard deviation of 1.5, then we will exit, or if it is going in the opposite direction, then if close price is less than simple moving average minus 0.5 standard deviation, then we'll come out of the position. So on the basis of that, we have defined one more column called position. So what we are doing is, if long condition, if there is we are in the long position, then the value will be 1. Otherwise, value will be -1. So this was the recap. I know I'm going a little slow, but it is important for some of the newcomers. Otherwise, they will not be able to understand. So you will be able to see in position we are getting multiple values. 1 is there, again 1 is there. So it is not possible. If you are already in the position, then we cannot keep on taking position. So if you are already have taken long, then we have to wait till the time it gets square off. So what we will do in that case, we will remove the duplicate values. I will define one more variable or one more column, position 2 is equal to np. So first let us declare position 2, initialize position 2 with 0. Then what I am doing is, I will see if the next value is also same. Then I will make it 0. Okay. Now there is a function in data frame. If we have to look the previous value, there is a function for that. We can look at the previous value using the function called shift. So here I'm saying if position, let us say this is the position, if it is equal to shift, mean the previous value, then I will take it as 0. Otherwise, I will use the same value. Let us see how does it look like. It is saying invalid function, invalid syntax. So why it is invalid syntax? It is invalid syntax is because in most of the programming languages, including Python, if we have to use, okay, we'll talk only about Python as of now. If we have to assign some value in some variable, then we use the equal operator like we are using here. This is this kind of variable. df position 2 is a variable. We are initializing this with 0. But if we have to compare it, one variable with another variable, then we cannot use this. We have, for comparison, we use this operator, double equal. Then it is not assignment operator. This is comparison operator. Let's run it again. Wonderful, it worked for me. Now let us see the values again. Don't you think it is showing too many columns? It is difficult for me to read. So because there are too many values, I will do one thing. I will shorten this. I just want close price. I'm not even looking at open, high, low, close. Just I want close. I'm looking at position 2. So this is the way to trim the data frame. We can just select the column which I'm interested in. Let us run it. Oh, it gave me error again. So it gave me the error because when I want to look for one particular column, then this square brackets are okay. But if I want to use multiple columns with the data frame, I need to give double square brackets. Yeah, it worked. Now the problem is I'm interested in 1 and -1. 1 means when I will take the position. -1 is when I will come out of the position. Then, but it has the value 0 also. I'm not interested in 0. So I will filter out those values. To filter out in data frame, we have this function. I mean, we can use this method, you can say. I'll just show it to you. df, first we need to write the name of the data frame. Then whatever criteria we want to apply, we'll put into it. Position 2. So if for comparison, there is a operator called double equal. For not equal, this is the operator. So I would say I want all the values of data frame where df position 2 is not equal to 0. So it will give me only 1 and -1, nothing else. Let us see whether it really works or not. Wow, this worked again. So I will do one thing. I'll store this value in the data frame, another data frame, to make it easy for me. So I have another data frame df2, which has only 2 columns, close and position 2, which I'm most interested in, and where the position values are only 1 and -1. So again, I will look at it. How does it look like? It's looking very good to me. So I just want to see visually how does it look like. So in data frame, there is one more attribute. We can plot the values just like Excel. Excel, you must have seen, we can plot some drawing. We can plot the chart. Similarly, we can do the same thing. You can consider the data frame is nothing but the Excel sheet. Only the functions are different. So I will do one thing, df2 plot. I can give the value, name of the function, column, which I want to plot. So it is showing me how Apple moved over a period of time. Now, but this is just for the close price. What if I want to see when it asks me to take the position? So in that case, I will add another parameter, that is position 2. Into it, and I will run it again. Oh, it is giving some weird look to me. Why is it so? It is because the close price is moving from 100 to 300, whereas the position is just -1 and 1. So if you draw both of them in the same plot, same chart, it will look like this. So what is the solution for that? There is a solution for that in the data frame. We can take another axis, secondary y. Just like y axis, we have secondary y also. Here we will take position 2. Oh, there are so many values into it. There are so many signals. So what we can do to reduce the signal, instead of SMA period 10, 5, let us make it 10. Just for example. And what I will do, here there is a tool, runtime. I can restart and run all. There is a function like that, by which I can rerun all the statement at one time itself. I will do that. So you can see it is running one by one all the cells. I think it is completed. Fine. We'll move on then. So now we have the signals with us. Now we have the values. Let us calculate the returns. So what I will do, first I will see how df2 looks like to me. So actually what is happening is, 1 means we are buying, -1 we are selling. It means we are buying at 1 is this price and we are selling at this price. So if we have to calculate the return, how we will calculate? We will calculate sell price. Sell price will be 129.996 and buy price is 132. So we'll do like this. So whenever the value is -1, then we will take that value as a sell price and divide it with the value of when the position was 1. So we'll do like this. Return. Again we will use NP where, because we need some, we will be using some particular condition to calculate this. So if df goes to is equal to -1, then we'll put it in the parenthesis, in the brackets. Then I will take df2 close. So for calculating the percentage return between this and this, I may need to do close price and previous close price divided by previous close price again. So there is a simpler way of doing this. In pandas we have percentage change. So what does it do is, value of this, what was the value before, how much percentage change happened since then, it calculates like that. So otherwise 0. So I'm running this again. Wow, it's giving me error. Operand could not be broadcast with the shape. Anybody understood why there is an error? The error is because we are using df2 here. df2 is the filtered set, is a subset of df, and by mistake we have used df again here. So that is a superset of df. So if you're trying to do the calculation between two different data sets of different sizes, then it will give this error. So I have corrected this. Wow, it worked for me now. So now you can see the returns here. It doesn't look too good to me. So what will I do in that case? Let us see how much is the return. Let us draw a graph now. df2 cumulative returns. So there is a function in data frame called cumsum, that is cumulative sum, that calculates the cumulative sum for that particular column. So I will do that. I will draw the graph again. Oh, it looks very bad to me. It's all going in negative. We are losing almost 80% into it. So this strategy didn't work for me. So let us say I have to create the strategy. It means I have taken some of the wrong variable, or maybe my strategy itself is wrong. What should I do then? So there is something better way of doing that. Now there are two things. Whatever we have done step by step. There are so many multiple statements which we have written, and it looks very difficult to read to me. Another thing, whatever we have decided, whatever strategy which we have taken, that itself went into negative. So I will show you something different now. So what I have done in this notebook is, I have taken the same code, whatever we have just wrote, in some better organized way. I have defined all the variable, all the libraries together here. Y, finance, date, time, NumPy, pandas. I have declared, initialized all of them together, and I have, whatever the steps we have performed, I have put them into one function called optimize strategy. Here I am passing the data frame as a variable. I hope you remember we have discussed how to define the functions yesterday. If anybody has any query, then we can discuss it again. But I can tell you again, function definition is nothing but the collection of the related statement into one particular section. So if we call this particular function, all the statements will be called together. One by one, they will be executed in the sequential manner. So I have put all of them together in the function. So what I have done, because I tried some simple moving average 5 or maybe 10, and I ran, and it went very bad for me. The returns were going in the negative. So what I have done, I have taken multiple simple moving average starting from 5. like 5, 7, 10, 15 till 50. And now I am running all the statements which I have defined before one by one, and I'm checking how much percentage return I'm getting in which particular simple moving average. So I will do one thing. So I'm not going through with these again because these are the all same statements which we have just gone through. I'm just running it again for you so that it will be visible what is happening. I think it is completed. So see, here it is calculating the returns of each simple moving average one by one. So first value is the simple moving average which we have applied. Another one is the returns. So it is for 5 simple moving average 5 it is 2, for 7 it is 15, for 10 it is 25, for 20 it is 63, 25 it is 64. The returns are little different from the previous sheet because we have taken different number of days here, and the standard deviation level we have taken little different here, otherwise the code is same. So if we see it closely, then the simple moving average 25 has the highest returns, and simple moving average 20 is also almost close to that. So it means those are the optimal value to run simple moving average crossover for Apple. So what we will do after that, what we have done, we have not taken value of 20, value of 25, we have taken something in between both of them. We have taken simple moving average period of 23, and surprisingly the results are much better than that. It is 71%, because we know 20 and 25 are the most optimum value, and that's why we have taken something in between of both of them. And now we have compared the returns of Apple with the returns with our strategy. So the blue line is the returns of our strategy, which is only long position, and another line is the returns of Apple itself over a period of time. So if we see, our strategy is much better than the Apple strategy itself because the drawdowns are very less, the series is very stable, and we are not invested throughout the period. Investment period is very less. So like we have seen in the previous notebook strategy which we have seen, which was going almost -80, here it is almost 70% profit. So this is how we can optimize our strategy. So some strategy, even though the strategy is not too good, if you optimize the parameters, it will start working for us. I hope it is understandable. I will come back to the questions. If you have any questions, please. Yeah, Ram is saying he wants me to explain line number 35. Okay, I will go back to that. Can you share the recorded video? Yes, we can share the recorded video. Can you share some resources to study? Of course, we have one more session. Let me explain in one more session. I will tell you all the resources. Where can I get the Indian market data? You can get the Indian market data also from Y Finance itself. In Y Finance, almost all of them are listed. How can we connect to NCDEX? We will let you know about that. We will connect to you. Somebody will connect to you from NCDEX about this. Okay, so I will take the questions one by one. First, Ram has asked to explain the line number 35. Let me go to line number 35. Okay, line number 35 is not here. Maybe Ram is asking about previous sheet which we have discussed. I close that sheet. So it is anyway, it is the same data. If you have any questions about this program, please let me know, because the program is same. I just organized this in the better way. I need video for both days to practice. Yeah, we can provide. Chitra will tell you about videos to you in some time. Chitra, I think I'm done from my side for today. Hello.
Okay, sir. Okay.
So,
Attendees, if you have any further question, would request you to please put all your questions in Q&A option.
yeah, I think most of the questions are replied. So,
Okay.
if there is anything, we can take care of that tomorrow. Yeah.
So we do have 2 more sessions on this. That is on tomorrow, 10th of May and 11th of May. And I've given the registration link here. I would request you all to please do register. Thank you, everyone. We have come to end of the session.
I will try to complete the session by tomorrow itself. So it is possible we may not need day after tomorrow session. We'll let you know by tomorrow itself.
Thank you, everyone, for your valuable time, and we wish you a wonderful day ahead. Thank you so much, sir.